So for today, we'll be looking at application of number base. So at first, we'll be starting with exclusive OR. And exclusive OR simply means XOR. And the symbol we use to denote this is what? Plus sign inscribed in a circle. So this is how we denote it. A plus sign that is inscribed in a circle. That is what? The mathematical symbol we use to denote XOR. So now, one thing about XOR is very simple, but you just need to know, because from here we are going to come up with a property that it is expected of every one of us to always remember that property. By the time we start explaining some algorithm in cryptography, and we are trying to use the XOR in our explanation. So now, for what I want to explain now is like we have a bit, right? Now, if I have, for instance, I have 1 XOR 0. We've already understand how to add numbers in base 2 already. So, but this one, there's a little different, like a change, and anomalies. The size was different. So just pay attention to the difference. Is equal to 1 XOR 0 will still give us 1. Is 0 XOR 1 will still give us 1. If I have 0 plus XOR 0 will give me 0. But if I should have 1 XOR 1, it's going to give me what? Normally in our normal addition, based on what we've discussed in the past, if I have 1 plus 1, where both numbers they are in base 2, right? So 1 plus 1 is what? Is 2, right? Is 2, right?
Yes.
So in that case, we won't put down 2. We'll divide that 2 by the base number, because in base 2, the possible number we can have in base 2, they are just 2. That is 0 and 1. That is number less than what? That base number. So that is why there is need for us to divide. So here it will give us 1 remainder 0. So we'll write the remainder here. Then this one will be carried, right? We are going to carry this particular one to the next number, right? So this is it here. This one is carried to this place. So I'll bring it down. So what I'm saying is that 1 plus 1 in normal binary means 10. That is the meaning, right? But here, 1 plus 1 here for XOR means is 0. Now, what is actually happening is that one that is carried will be ignored. You understand? This one that we carried here, it will be ignored. If it is XOR, which is exclusive OR. Please, am I making any sense? Yes, they are in base 2. Those numbers, they are in base 2. So this application we are looking at is under binary. You understand now? So all these numbers that we have here, they are in base 2. I believe you understand what I'm saying, right? Now, let us now come with an observation. An observation. So what I observe is that when we have same digit, same bit, it will result to to 0. Or you didn't notice that the bit here is 0, the bit here is 0. So XOR of same bit, what does it give? 0. The XOR of same bit is is 0. So we can conclude that if we have A, for instance, to be a bit, right? So XOR of A, what are you expecting? Is 0. You get the logic, right? And another thing is, if we have different bits, so what are we expecting? 1. So if I have A, XOR of is 0, what is my expectation? It is what? 1. Because when we what? Look at what we have here. If we pay attention to this, we'll see the what? The trend. That what? This one plus this. You know, there are 2 different what bits, right? 2 different bits will result to what? 1. So, but if you have what? Same what? Bit, it results to what? Is 0. So just to what? To in summary, same bits equal 0, right? Different what? Bits will give us what? Oh, sorry, different bits will give us 0. Sorry, different bit will give you 1. Pardon me for the mistake. So same bit will give us what? 0. Meaning when you are what? Trying to join them together with XOR. So it will give us what? 0. But different bit will give us what? 1. So it is very important for us to know this for safety. I believe that is clear, right? Now, is it clear? Any question? So let us look at bitwise operator. Bitwise or what? Operator. Now this bitwise operator is introduced in a scenario where we have multiple bits. It is what? Introduced when we have what? Multiple what? Multiple bits. That want to what? Carry a certain operation on those bits. So this operator we'll be looking at are, we have bitwise or, we have bitwise XOR, we have bitwise NOT, then we have bitwise AND. So when we look at some languages, starting from C up to any other language, we notice that OR, we use this pipe symbol for it to denote what? The OR operator. We use this to denote the OR operator. For the XOR, we use this caret symbol. NOT, we use this. And for the AND, we use the ampersand sign. This ampersand was symbol. So we'll have come across this in all these languages that we know about. Okay? Which one? XOR. Yes, we use the symbol. But that symbol is how you pronounce the caret. Like this. That is the symbol. This is the symbol. This one is just the name you call it. Which one? This one? This one? Yeah.
Why is the caret and the other one is
why is what?
This one caret.
And this one O.
No. This is caret.
Yes.
The calculation we did on the left hand.
Yeah, okay, I get your question now. Mathematically, you know, this one is what? Program, like writing of language, the symbol used while writing language. But the mathematical symbol for it is this plus inscribed in a circle. I've answered that right. So we are going to check it out on Persian to see how this thing works. So now, let us look at, we've known those words operator. So let us look at how it works. Now before we'll look into that. Now we have what we call inclusive OR. this inclusive OR is the same thing as this inclusive OR is the same thing as our bitwise OR, and we have exclusive OR. We have what? Exclusive what? OR. So let me just what? We want to look at a distinction between the two. So now, for exclusive OR, if I should have 1 caret of what? Is 0. What are we expecting? Is 0? Is 0 this of this? You know, this one means exclusive OR is what? It is representing XOR, right? Okay. So this one, if I have 0 XOR 0 is what? And if I should have 1, if I should have 1 XOR 1 is what? Everything here is what we've what? We've put down here, right? So that means 1 XOR 0 is what? 1, right? 0 XOR 1 is what? 1. 0 XOR 0 is what? 0. Is 0, right? Is 0. And 1 XOR 1 is what? Is 0. Now for inclusive. Inclusive in the sense that if you have same digit, you still retain that digit. Now, yeah, if I should have 1, the pipe symbol, right, of I'm coming. If I should have 1 of 0 to be what? 1. And if I should have 0 of 1 is what? And if you have this of 0 is what? And if I should have 1 or of 1 is what? Now 1, when you have different word bits for the whole, is going to give us 1. When you have this one to receive what? 1, right? This one, when you have same word digit, same digit is going to be equal to what? This one is still 0. It's still what? It's 0. But 1 is going to be what? 1 in this case. Do you understand? 1 is going to be what? 1 here. And not what? Is 0. So the only difference between this inclusive OR and the exclusive OR is what? This word 1 XOR 1 give us what? 0, right? Meaning here, you know, in our normal addition, we write the remainder carry, right? So here we did not what? Carry anything. Do you get it now? So this part, you didn't need to carry anything. So 1 XOR 1 is what? Is 0. But 1 OR of 1 will give us what? Will give us 0. Oh, sorry, will give us 1. Sorry. Let me just write the summary so that we can always what? Remember. The summary is what this one is just trying to tell us is that when you have same bits, so you retain that value for each of the bits. The value will be equal to what? One of the what? One of the bits. Here we have here for this we have same word bit, right? 0 is 0, right? It's same, right? Now the inclusive OR of it will still be what? That same bit. Just retain one of this as the value. The same thing is applicable to this, right? Same value, right? So you retain one of it because it's same. So we retain one of it, that is what? 1. Unlike this one, exclusive, meaning you are excluding it. Once they have same or digit. For this one now, for this same bit means you are going to have what? 0. None of the what? The 2. So you have what? 0 in this case, meaning none of the what? The 2. None of the 2. You see that here is the same, right? Here is the same, right? But you might be saying that here is not the same, but the answer is expected to be what? Is 0, right? So this one too, same thing, 0. I believe you get the summary right. Are we okay with the summary? Before we look at question under this. The mathematical representation of that, so, well, we can still use this normal plus, but I didn't know of that. I only know of this. Do you understand? But it depends. You know that yes, you are still what adding, but you can decide to what to use this symbol. You understand? You can decide to use this symbol direct, but mathematically we have this symbol for what? Exclusive or. Yes. Okay. If you have true or what or false, right, it will be true. Correct. If both are what false, it will be false. If it's true, it's true. Nice one. You know that we have logical and logical or. Logical what and use what two ampersand, two of this symbol. And if it is what logical what or, it is two what pipe symbol. Logical and use this. You get? So that is that for that. I believe we are okay with this, right? Now let us look at the question under this. Let us look at question under that. So now, I have this as a question, 5 XOR 3. I want to look at 5 or 3, right? Bitwise or 3, right? So it will be equal to what? Now here now, we need to what? To know the equivalent form of 5 in base 2, right? And also we need to know the equivalent form of 3 in base 2. All together. Yes. We'll do that after the class. So now, for this 5 now, if you want to what? Get the equivalent form of that 5. Because each of these are in base 10, right? If I have 5 now, I want to take it to what? To base 2. I'll just be dividing repeatedly by 2, right? So it will be 2 in 5, 2 remainder 1, right? 2 into 1 remainder 0, 2 in 1 is 0 remainder 1. So our answer will be what? Taking from the bottom to what? To top. That is what? 101 in base 2, right? And for this 3 is what? 1. We all agree with me, right? Yes. So now we want to look at this or 3, right? What will be the word? The answer. So if I have 101, then I have 1. You know, we want to add, right? So here now you see that this one is of how many digits? This one 3 digits, 2 digits. So we need to complement something here so that there will be of equal digit, right? That should be what? 0. So here we have 0 here. So now you remember what we have in the previous page that says that what? 1 or 1 is what? Is 1. Is 0 or 1 is what? 1. We have 1 or 0 is what? 1. Is 1. And is 0 or 0 is what? 0. Right? Now this is what we use as a guide for what we want to do. 1 or 1 bitwise of or of 1 is what? We have it to be 1, right? So you write 1. What is 0 plus 1 in this case? It's still 1, right? And 1 plus 0 is still what? 1 here, right? So this is the what? The binary form of this, right? So we have the binary form to be what? For 5 or 3 to be 1. But since each of these values we have it in base 10, so it's our duty to what? To take it to what? Base 10. So let's take 1 to base 10. So let us use the weight method I explained earlier yesterday, right? So what should be the weight of the first number to the right? It will be 1, right? And we know that consequence what? Weight will be what? 2 times than what? The previous one, right? So if this one is 1, you know the base number is 2, right? So it will be that we multiply 2 to this. 2 times 1, 2. 2 times 2, 4. So it's going to be what? 4 times 1. 4 times 1. Pardon me, so we have a new student on this. So we have 2 times 1, then 1 times 1. Praise, do you get it? So it's going to be equal to 4 plus 2 plus 1, and that gives us what? 7. So that means 5 or 3 will give us what? 7. So we are going to check this with PyCharm. We'll test it on PyCharm whether what we are doing is what? Is correct or wrong. The idea is we knowing how to what? Whiteboard what we are doing, and when we go into what? Into text editor, we can also what? Get same result. That is the idea. But if you are getting a contradiction, that means something is wrong somewhere. So now let us look at another one. I will also give you what to do yourself. We will now go to the what? To the text editor to check it out whether it is same or not. Now let's say I have 7 XOR, let's say XOR 5 for instance. Now the idea is I need to know what 7 represents in base 2, right? Now 7 in base 2, 1 1 1. Okay, that is 1 1 1. And 5 in base 2 is what? 1 0 1, right? You know the idea is to do what? Is to add, right? So now 1 all of 1 is what? Is still 1, right? Am I right? 1 all of 0 is what? Is 1. And 1 all of what? 1 is what? Are you sure I'm right? There is a contradiction. I'm wrong. We are wrong in the sense that this value here, sorry, okay, we are correct, sorry. We are correct. So we have 1, we have what? 1, right? So now this one, when we convert, you will see that it will still result to what? To 7, right? Abina?
Yes.
Okay. So let me give you what to do.
So it's possible to have the same value for different operation.
For different what operation?
We have actually
okay. Sorry, let me get you. Now. Yes. Yes. Okay. So you know what? We'll what? Reason together. Do you understand now? We'll reason it together. So now, here we have different value, right? According to him. You know what we have here now is what? Inclusive or, right? Is what? Inclusive or. So, and I said something that when we have same digit, it results to 1, right? Same digit result to 1 here. Like you will retain that same value. Like same bit, meaning it will return one of the bits, right? And the same thing for this, 0. But here, 5 is a what? Is a bit on its own, 3 is a bit, right? So now, you remember what we are dealing with here now, we have it in what? In base 10. Each of these numbers is in base 10. So the idea is we using our knowledge of what? Of base 2, the knowledge of base 2 to deal with it, then we'll take the answer back to what? To base 10. So when we perform based on this basic idea that we have here, we are able to what? To solve 5 and 3, the inclusive of 5 and 3, and we discovered that it results to what? To 7. And for this one now, we have 7 and 5. The inclusive of these two word bits result to what? To 7. So the question is there any word observation, right? Is that what you are saying? Why this plus why this inclusive of this is equal to 7? Not here. Let's see what continue. So we can what? Come up with something. Since this is a learning environment, you can observe something. You understand? So I can't say maybe here we have an identity element. This is not binary operation. You understand? But what we have here, though, this is we will say is a binary operation, because an operation between two operand is what we call a binary operation. Where are the operand here? The operand are what? Sorry. The operand here is what? This and this. And this is the operation what? Sign in between them. So this is an operation between two numbers. That is why it is called binary operation. You get my point? Yeah. But in binary operation, we have what we call identity element. Identity element is what? That element that will combine to another element to give that what? Element back. You might not understand. Let me do guys something down here. Now, for instance, under this operation, addition, we have an identity element. That is what? 0. So if I have an element A plus 0, what are we expecting? A. Anytime we had 0 or maybe a number is added to 0, the outcome will be what? The other number. So that means this one is what? Is the identity, or we call it what? Neutral element. No, we are still working with what? A binary what? Operation. So we can still come up with what? A trend. Because here 7 combined with what? 5. What does it give? 7. So therefore, what are we going to say here? What is the identity element here? It is what? 5. Because when you compare this to this, same thing is happening. And also under this operation, multiplication, it gave us 7, right? So that means this aspect now, there is no what? Identity element. You get the logic? So there is no what? Identity element. So like under this operation, multiplication, if you multiply any number by 1, what will it return? It will return that other number. So the identity element here is what? Is 1 under this operation, multiplication. But you see that we are not looking at addition, multiplication, irrespective that this inclusive or is a form of what? Addition. But not, it's not using this word symbol, this dagger form of symbol. You get the logic? So now, I want to give you a question to do, to build on. So this is what you do. You do 8 or of 3, 9 or of 8. So your time starts now. The solution of the given question. So for this first one, where we have 8 inclusive or of 3, so 8 or of 3, so we need to know the equivalent form of 8 in base 2, right? So and the equivalent form of 8, what will it be? 1000. 1000. 1, 2, 4, 8. Yeah, 1000. And 3 is what? Is 1, 1, right? So now, you see that 8 is 4 bits, right? But 3 is what? 2 bits. So let's try to what? To make them to be of equal bits. So we add 2 0 to this. You know, is 0 or of 1 is what? Is 1, right? The 0 OR of 1 is what? 1. The 0 OR of 0 is what? 0. And the 0 OR of 1 OR of 0 is what? Is 1. So this is what we have. We need to take this one back to what? To base 10. So let's convert this value to base 10. You know, the power, like, why using the word? The weight approach. So here is of weight 1, 2, 4, then 8, right? So 8 times 1 is what? 8. 4 times 0 is what? 0. 2 times 1 is what? 2. 1 times 1 is what? Is 1. So the addition of everything results to what? It results to what? 11. So we have 11 here, right? Is that what you have?
Yes.
So for the second one, where we have 9 inclusive OR of 8, we need to know the equivalent form of 9. So the equivalent form of 9, what will it be? 1, 1, 1, 1, 0, 0, 1. Yeah. So that is the equivalent form of 9. So, and 8 is still what? 1, 0, 0, 0. Though there is a pattern in drafting all these numbers, but I probably would overlook that. So you can observe the trend on your own. So while looking at the pattern, it's just like alternation of 0 and 1. Trying to convert from writing numbers in base 10, like starting from 1 downward. You observe the alternation in 0 and 1 while looking at the column. So here we want to add 1 OR of 0 is what? 1. The 0 OR of 0 is what? 0, 0. Then this one is 0, 0. This one is what? Is 1. Right? So we have it to be 1, 0, 0, 1. So this one now we need to what? To change it to base 10. That is 1, 2, 4, 8. So here we are going to what? To discard what? Those digits with 0. We'll just focus on the one with non-zero value. 8 times 1 is 8. 1 times 1 is 1. Then it results to what? 9. So this one, 9 is inclusive OR of 8 will give us what? 9. You can see now this one is what? Illustrating the what? The identity what? Element property. Meaning 9, when 8 combined to it, it returns what? 9. So the identity element in this what? Scenario now will be what? 8. So now let us what? Try to what? To check this one out on bitwise and we want to look at what? Bitwise what? And
This bitwise and the bitwise this is like a normal and
wait, oh, the bitwise what?
bitwise and bitwise of when I think the same as the normal one that we use.
No, there is a little difference. So you just need to note those words difference. So we want to look at the hand, right? You know, the bitwise hand, we use this symbol, right? This symbol. So now if I should have a 0 and 1, 0 and 1 will give us 0. 0 and 0 will give us 0. 1 and 0 will give us what? 0. But 1 and 1 give us 1. Do you get it now? Like, it's just like we looking at the Boolean, talking about true and false, right? So if I say false and true, because 1 will be seen as true, right? So since both of them is not what? True, it will be what? False. So false and false will give us what? False. If you have what? True and false. True and false will give us what? False. But if you have true and true, we give us what? True. I guess that is what is happening here.
Yeah.
Because false is what? 0. True is what? Is 1. So now, what we just need to do is that anytime we want to what? Consider bitwise AND. Bitwise AND is what? Is applicable to what? To corresponding what? Bit. Like for instance, let's say I want to find 5 and 3 for instance. 5 and 3, you know 5 will give us what? That is 1 0 1, right? Yes, 1 0 1. And 3 will give us what? 1 1, right? Now here now, you will see that up here, what we are having up here is how many digits? 3 digits. What we have down here is how many digits? 2 digits. So we need to make what? This one too to be of same digit, right? So that means we will need to add a 0 here to complement that. So now, corresponding what? Like, corresponding bit is the one that will multiply, not the normal way we do what? Our multiplication. You remember, the normal way we do our multiplication is pick this one first, use it to multiply everything up here. You pick this one next, use it to multiply this one. You know, the result will be shifting. We'll be having what? A shift, right? Inward. So you then add the result. It's not like that. Here it will be what? Corresponding what bit will multiply. So that is how you do it. So let's do it together. Now 1 and 1 is what? 1, right? 0 and 1 is what? Is 0. 1 and 0 is what? Is 0. That means we have 5 and 3 in base 2 to result to 0 0 1. And the 0 0 1, if you want to take it to base 10, we still give you 1. Because this one, if we should what? Distribute the weight, we have 1 2 4. So this one will be, we'll discard this one, then it will be 1 times 1, which is what? 1. So here we give us 1 in base 10. So 5 and 3 result to 1 in base 10. So now let us look at another example. Let's say I have 9 and of, let's say, and of 5, for instance. So 9 is what? 1 0 0 1. You can check it out. 1 2 4 8. That is 8 plus 1. So and 5 is what? 5 is 1 0 1, right? 1 0 1. You know, we need to complement this with what? 0, right? So since it is and 1 and 1, true and true is true. False and false, you know now, is what? Is false. That is 0, right? This one is what? Is 0, is 0. So the answer is still what? 1. Because when you convert this one in base 2 to base 10, we give us what? 1. Do you get that now? Now you are going to do this for me. Practice question. Practice question. 7 and 6 and 13 and 9 and 9. Now, solution to the question, we have 7 and 6. So it's equal to, the equivalent form of 7 in base 2 is what? That is what? 1 1 1, right? So and 6 is what? 1 1 0. So here now, say it is and we want to look at, and you know it's more like this is the summary of what is happening. So 1 is like you have a true. 1 stands for what? True, and 0 stands for what? False. So when we have 1 and 0, it is what? It's 0. 1 and 1 is what? 1. 1 and 1 is what? Is 1, right? And that is what? 1 1 0. And from here, we've seen that 1 1 0 is what? 6. So when we convert this one to what? To base 10, it gives us to what? To 6. The next one is what? 13 and and 9. So 13 to base 2 is what?
1101.
1101.
1101.
This 6, you will convert this to base 10. Yes, because what is given to us, they are all in base 10. You say what? Yes. You can use the weight format or the exponent format, any of the two. Now 9 is what? 9 is 1001, right? Now what we multiply? 1 and 1, 1. 0 and 0 is 0. This one is 0. Then this one is what? 1. So when we convert, you see that is what? It will result to 9. So you notice that for this question, those two questions even illustrate this identity element. In each of these binary operations, we can what? Tell that what this is what the identity element. So if I may ask, for 7 and 6, that result to what? C. What is the identity element? 7. Thank you. And then 13 and 9, that result to 9. What is the identity element? It's 13. Identity element is just what? An element that combines to what? Other element to give the other element as what? Answer. It has no effect on the other element. That is the meaning. For instance, 0. If 0 added to any number, we return that number back. 3 plus 0 is 3. 2 plus 0 is what? Is 2. That makes what is 0 to be an identity element under the operation addition. And for multiplication, the identity element is what?
1.
Is 1. So bitwise XOR. So now let us look at question under this. So if I should have 5 XOR 9. So we use this what? Caret what? Symbol to denote XOR. And you remember the rule, if I should have 1 XOR 0, give me what? 1. 0 XOR 1, give me what? 1. 0 XOR 0 is what? Is 0. But 1 XOR 1 is what? Is 0. So it is important we what? We take note of this. So 5 XOR 9 is what we want to deal with, right? Now 5 is what? In base 2. It is 101, right? And 9 is 1001. 9 is of what? Higher digit than what? The 5, right? So we need to complement this one with what? 10, right? So now, if I have 1 XOR 1, it is 0, right? 0 XOR 0 is what? Is 0. 1 XOR 0 is what? 1. And 0 XOR 1 is what? Is 1. So this is the what? The binary what? Result we are going to have, right? So let's convert it to what? To base 10. So here you have, it will be 12. Here we have 1, we have 2, we have 4, then 8. So it will be 8, that is 8 times 1, 8 plus 4. So that is 12. So 5 XOR 9 result to 12. So let's look at another question. Let's say we have 13 XOR 15. Now 13 in base 2, we need to find that 13, 6 remainder 1, 3 remainder 0, 1 remainder 1, 0 remainder 1. So for 15, I have 7 remainder 1, 3 remainder 1, 1 remainder 1, 0 remainder 1. Thank you. So 13 is what? 1101, right? And 15 is what? 1111, right? So now 1 XOR 1, 0. 0 XOR 1. 1 XOR 1, 0, 0, right?
Yes,
So
sir.
now let's take this reward to base 10. That is 0, right? Oh, sorry. 1, then 2. We have 4, 8, blah, blah, blah. So the answer is what? Is 2. You get it right? So now this is the question you will do. You do this. Your the practice question. You have to simplify this. 17 XOR 10 and 15 we have 19 XOR 23. So your time starts now. So we have 17 XOR 10. So is equal to, we need to convert 17 to base 2. So 17 in base 2 is what? What is the value of 17 in base 2?
1 0 0
1 0 0
0
0
1.
1. This is it, right?
Yes.
So we have 1 0 0 0 1, and 10 in base 2 is what?
1 10 10.
10 10.
You need to give it
In how many?
Not on your head. That 10 is 10 10.
It's 10 10.
10 10.
10 is what?
10 10.
1
1 0 1 0.
1 0 1 0 1 0 1 0, right?
Yes, sir.
So it's going to be 0 1 0 1, right?
Yeah.
So and we need to complement it with 1 0 here. So the 0 will be here. So now 1 XOR 0 1 1 0 1 1. So this is what we have, right? So let's convert it to what? To base 10. So we have 1 2, we have 4, we have 8, then 16. That is 16 plus 8 plus 2 plus 1. So we have it to be 27. So that means 17 XOR 10 result to 27.
As 10
Yeah.
Wow.
So 19 XOR 23. 19 XOR 23. So is equal to so though I'm going to give an assignment, let's see. It might be a little bit logical, but it's nothing. You will find a way around it. I trust you guys.
Okay.
So 19 in base 2 is what? 1 0 0 1 1. 23 in base 2.
1 0 1
1 0 0 1 1.
1 1 1.
10 1 1.
1 0 1 0
1 1
1 1 1. So now we have 19 to be 1 0 0 1 1. 23 is 1 1 1, then 0 1. So 1 XOR 1 is what? 0 0 1 0, then 0. So we have it to be 10 and when 100, sorry. So and that is 8. Oh, sorry.
That's 23 plus
That is 4, sorry. So 4 times 1, that is 4. So 19 23 XOR 23 will give us the 4. So now I want to look at bitwise NOT. So bitwise NOT it is not a binary operator because it only operates on one bit. So this is the symbol. It only operates on one bit. So in this case now, if I should have not of 0, not of 0 will be what? 1. Meaning not false. That means it will be true. So if I should have not of 1, it will be what? It will be 0. Meaning if something is not true, that means it will be what? It will be false. But what of if we have more than, if we have more than what? 1 bit. Do you get it now? Something should what? Should happen. So here now, let's say we have 5, for instance. I want to find the what? The knot of what? Of 5. We want to find the knot of what? Of 5. So how are we going to get this? Now, you know, normally if you convert 5 to base 2, 5 in base 2 is what? Is 101. Right? So each of these, you know, is not single what bit that we have here. And the idea is it must what? Only what? React on one bit, right? 1 byte. So if you want to know your answer direct, because if I just say I want to what? Flip this what? Bit now. So it will be that the XOR of this one will be what? 0, right? Like the negation of this will be 0. Of this, not of this will be what? 1. Not of this will be what? Is 0. But this is wrong. This is not what our answer. So there are 2 complements that is being used here. First complement and second what? Complement. And there's another thing what we call what? Place sign. Like sign bit, sorry. So for sign bit, if we have 0, it means it is positive. So if we have what? 1, it means it is what? Negative. That is for the what? For the sign bit. Now here, this is what we have. 101, right? So the sign will be what? Placed here. So, you know, the value that it should be here should be 0, right? So the sign is what? Is 0 here. Like that means it is positive, right? It is what? Is 0 here. Meaning it is positive. But when we what? Flip, as we are what? Changing this, flipping what this. This one will be flipped.
You said 0 is positive.
If 0 is positive.
But that's a minus sign.
No, this one is just a line, just to differentiate what we have here from this. You get? So we have 0, 1, 0. This is what we have, right? But this one is the what? The sign bit, right? So where is this 0 coming from? You know, here it should be 0, that should be here, right? So that means we have what? 0. But that means it is what? Positive, according to the what? To the sign bit, right? Positive. So yeah, this value that we have here is wrong, because if we should convert this value to base 10, it's going to give us 2. And when you will check this, when we run it on PyCharm, it will give another answer. Positive result what? A negative result. But even the negative result, we didn't have a clue yet. What will be the answer? But at the end of this, there will be a summary on how to get the answer. So now, this is not the answer. I said we have two complements, right? The first complement is that we have to flip this thing back. The first complement is flipping of the bit. So if I flip this one, what will it be? 1 for this become 1, right? For this 0, then this 1, meaning it's going back to the original question. So since it's positive number you are dealing with, what you don't need to have in mind is that you add 1 to its binary form. So if I should add 1 to this, I will get the negation of 5. Like the bitwise not of 5. So what is 1 plus 1 in this case? 0 carry 1. So this all work as if we are adding our normal binary. So 1 plus 1 is 10, right? It will be 0 carry 1. 1 plus 0 is what? 1, then we have 1. B is what? 1, 1, 0. So this one to what? To base 10. You have what? 1, 2, then you have 4. That is what? 6. So this is representing 6. We get. Now let us look at another positive values. Let's say I have 7. Let's say we have what? 7, right? Or probably, let's look at it from this angle. What do we have here? 5, right? 5. You need to add 1 to it. What does it give? 6. Then convert this 6 to what? To base what? To base 2. Or there is no need. This will be your answer. Because you need your answer in what? In base 10.
That means this 5 not 7 will give us 8.
Of what? This one will give us what? 8. You get the logic? It will give us what? 8. But if you want to go with the binary what? Approach. So, 2 complement is what? Is involved. So you get. Since it is what? Positive. Just have the in mind that yes, if I should even take this one to involve binary form, I will need to add 1 to it, right? So after adding 1 to it, it will give me what? Another binary result that I will need to take back to what? To base 10. And that will be what? 8 in base 10. So if I should convert 7 now, 7 to base 2 is what? 1, 0, 1. No. 1, 1, 1. It is what? 1, 1, 1, right? Now, if we should what? Flip, or without flipping, because we know that this one is what? It is a positive value, right? We need to add 1 to it to get our answer right. So 1 plus 1, 0 carry 1, 0 carry 1, 0 carry 1. So this one is 8. What we convert? Which is what? 8. And it is the same thing as this. Now what of if we have negative? What of if we have what? A negative what? Result. Now let's say we have minus 5. Yes. The binary of this one. No, we can flip this one too. We have 7, right? That is 1, 1, 1, right? When we flip it, we have 0, 0, 0. But 0, 0, 0, when you convert it to base 10, it's 0, right? But we know that what? This is not the answer. You get? This is not the answer. You remember there will be a sign bit at the front, right? And that sign bit is what? It is determined by this, right? By this. 0 is positive, 1 is what? Negative. So as you are flipping this, you also flip what? That sign. So initially we have it to be positive. So it will be what? It's 0, right? It is 0 initially. So by the time you flip it, it becomes what? 1, right? So we've already flipped this one, but we know that yes, this one is not the answer. So that means since we know that it can't be the answer, we need to consider what the rule, right? That is the 2 complement. The first complement is what? We flip, right? So we need to flip this. We need to what? To flip this. So when we flip this, it will go back to this. That is 1, 1, 1, right? Then you add 1 to this. So when you add 1 to this, it gives us what? 1, 0, 0, 0. You get, right? So that is that for that. And the sign that will be at the front, because you need to what? To flip this. So when this one is flipped, you have it to be 1. So that means it will be what? Negative. It will be what? Negative. This one should be minus 6. This one should be what? Minus 8. So if you write 6, you are wrong. The answer is what? Negative 6. Because of the what? The sign bit. Please, I hope I'm not confusing you.
Yes, you have, actually. Initially, we agreed that the answer was the answer to negative not of 5 is 6. Now you're saying
No, it will be negative. I said something that if it is what? Negation of, like if you are looking at the not of a positive value, it will result to a negative value. So there is a sign bit. So you also flip the what? The sign bit. So when it is what? It was 0 initially for the sign bit of this question of the not of 5. So again, after flipping it, so So you get? Yeah, it become 1. So that will be what? Negative. So we want to look at negative now. Now let us look at, it's negative 5 we have. What of if you consider 5? If we consider what? Positive 5 now. So if you consider positive 5, what is the equivalent form of this in binary? Or probably this is how it works. The shortcut, just add 1 to this. So you get, add 1 to it, what does it give? Negative what? 4, right? You flip the word, the sign, that is 4, right? So when you what? Take this 4 to what? To base 2. Sorry, it will give you what? 4. So here you have 4. Plus 4. So if I should have minus 6, sorry, I said minus 6. Negation of, pardon me. This of minus 5. This of minus 6. You get?
Okay, let's play that negative or positive. We just add
1.
That's all. Whether I'm one complement or 2 complements.
But if you want to take it to that word flipping part, the flipping, you must know how it works. Shall you understand?
If it is positive, you flip to negative.
Yes, I'm coming. Okay, now let us what? This one now. This one, not of negative 6 now. Not of negative 6 should give us what?
Minus 6 plus 1.
That is, if you have minus 6, that is what?
Minus 5.
5.
See, minus 6 plus 1 is what? Is minus 5.
Yes,
So you flip the word, the sign, so it will become plus 5. Do you get it now? So what of if you want to what? Do the flipping to verify, maybe we have 4 for this. It's difficult.
Okay, to verify.
So let's try it out and see. It was minus 5 that we have here. It was minus 5 that we have here, right? So that minus 5 that we are having here, so let us first consider when we have positive 5. If you have positive 5 in binary, it is what? 1, 0, 1, right?
Yes.
So if you want to flip this, it will be 0, is 0, 0, sorry, 0, 1, 0, which we know is not the answer. It's 0, 1, 0. This can be our answer, right? Because it's 2. So here now, what we need to do is what? What we need to do is this. We'll consider the word, the 2 complement rule, right? So we'll first flip the word, the bit. That will be 1, right? 0, then 1, meaning it's going back to the original question. Then you add what? 1. So when you add 1, what will it give? We have 0, right? Carry 1, so 1, 1, right? Yes. This one is for what? When we have 5, right? But you know that the sign, you also flip the sign. It was positive initially. When you flip it, it becomes what? Negative, right? For the sign of this one, for the sign, it was 0. Because the sign B says 0 is positive. So after flipping, it becomes what? 1. So that means the sign in front of it will be negative. Because 1 is what? Negative. So this one is what we consider what? Positive, right? Now, you saw what? Yes, yes. Now, if we have negative of 5 now, negative of 5. So for this one now, we'll need to take what? We'll need to flip it, this result. We flip it. So when we flip it, we have 1.
Which one?
This.
You know this, it's not true.
This one. So when we flip it, what will it give? We have 1, 0, 0, right?
Yes.
Is that all we have?
Yes, sir.
Then what are we going to do? We had 1. We had 1. So we have what? 0 carry 1, right? 1, 0, right? So this one is on to what? When you convert, this one is 2 now.
Yes.
But our answer is what is 4.